How do carbon-negative building materials sequester CO2? Imagine a building that not only uses eco-friendly materials but actually pulls carbon dioxide out of the air and keeps it locked away. Sounds like a dream, right? Well, it's becoming a reality thanks to innovative building materials that are carbon negative. These materials do more than just reduce emissions. They actively remove CO2 from the atmosphere during their creation and use. Let's explore how they work. The main way these materials sequester CO2 is through biological processes. Think about timber, bamboo, hempcrete, or straw. Plants absorb carbon dioxide during photosynthesis, turning it into organic matter. When we harvest these plants sustainably and incorporate them into buildings, the carbon stays trapped in the material for decades or even centuries. This turns the building itself into a carbon storage unit, helping lower overall atmospheric CO2 levels. Another method involves chemical reactions called mineral carbonation. Some new types of concrete substitutes avoid traditional cement, which releases a lot of carbon dioxide during production. Instead, they use industrial waste like steel slag or mineral byproducts. During manufacturing, carbon dioxide is injected into these materials where it reacts chemically from stable minerals such as calcium carbonate or magnesium hydroxide. These minerals lock away the carbon permanently, making the material stronger as it cures. There are also emerging technologies that mimic natural processes. For example, scientists are developing ways to grow sand-like building materials in seawater by converting carbon dioxide into mineral forms through electrochemical reactions. This process captures CO2 during production and turns it into a solid mineral that becomes part of the building material. Using these materials in construction not only helps sequester carbon but also boosts energy efficiency. For instance, hempcrete and straw bale insulation store carbon and improve thermal performance, reducing heating and cooling needs. Carbon-negative concrete alternatives can replace traditional foundations and walls, lowering the embodied carbon of the entire building. In practice, architects and builders choose sustainably harvested timber or bamboo for structural elements, incorporate hempcrete or straw for insulation, and opt for mineralized concrete substitutes. Combining these with passive solar design, smart ventilation, and high-quality insulation creates homes that use less energy and emit fewer greenhouse gases over their lifetime. Mastering sustainable architecture means selecting these materials carefully, ensuring their production keeps the carbon-negative balance, and integrating them into building systems that minimize energy use. This approach turns buildings into active participants in fighting climate change by sequestering CO2 and reducing overall emissions.